Hello friends, welcome to Kumbha Science Academy. Today we will complete our differentiation part 2. So differentiation part 2 means what? So we were started with this exercise number 1.2, out of which we solve the question number 1. Now we will solve the question number 2 of that exercise within this part. So most importantly, hopeful you are working on these problems separately. So these problems are not that difficult and they have their own solutions. Initially we solved those problems, now again we are repeating these problems, but we are repeating in different manner. Now what we are doing, we are finding the derivative of these problems with respect to y. How? Just converting those functions in terms of y by taking their inverse. Okay, now let's focus on question number 2 of the exercise. So question number 2 says that find the derivative of the inverse function of the following. Okay, for what? Y is equal to x square into e raised to x. Now it is quite difficult, but not that difficult part. It has its own field. Now how it is difficult? So exercise number 1.2 of differentiation by inverse process, we are solving these questions. Now question number 2, out of which we are solving question number 1. So y is equal to x raised to how much? X square. So that is what? X raised to 2 into e raised to x, x raised to 2 dot e raised to x. Now what to do, sir? How to convert? So here also we need to find out the first inverse of this function. So we first find inverse of y. So that's what I am writing only. Okay, so nothing else we need to add here within this statement. So simply find the inverse of this function. How it will be working? So y is equal to x square into e raised to x. Most importantly, what to do with this x square? Okay, and what to do with this log? So most of the students are thinking like you take the under root and then we can find the x. Okay, so that's not the case. Just take the log on both side. Okay, so if you take the log on both side, so you will have the particular value. But again we need to find in terms of x. We need to find the solution in terms of x. So what should be the procedure? Now here you can see this is what? The product of two possible values. So what is that product? This is what? X square into e raised to x. You can see. So I can take them in terms of x and y. Now here most importantly, if you take the inverse of this whole function, okay, there might be chance you will struggle with one particular thing. So whatever we were doing in question number 1, we are just following that step. But what is the difficulty? If I look at it properly, what I am looking, if this equation is like this, the taking log on both side, log of y is equal to log of x square dot e raised to x. Now next step, now this will be applicable for the product rule. So log of x plus x square plus log of e raised to x. So which is nothing but 2 log of x plus x log of e, which is 2 log of x plus x. Again, what is the situation over here? X. Now what is this y? What is the situation? Log of x. So we are not able to separate it. Okay, again we are having the problem. So log of y is equal to this whole scenario. Now do we have any hint in between that? Okay, so if you want to apply this equation, so if you want to solve this equation, so it's not that easy, okay, to solve it directly. What we need to do, we need to split these two terms separately. Now how we will do it? Okay, so you got the problem, you got the situation. What is the main problem? We cannot directly find the inverse of this x square and e raised to x. Okay, so here what we need to do, we need to, so if you look at it, are we getting this value in terms of x? No, here again the log of x is separately haunting us. So this log of x is separate, so this whole term again is problematic for us. Understood? So if you take a derivative on this side and this side also, so you will have this problem. Now in terms of finding x inverse, so let, okay, so in terms of finding this, let u is equal to x square and v is equal to e raised to x. So inverse of u in terms of x, okay, and inverse of v in terms of x. Okay, so can we see it? Yes, of course. So x is equal to under root what? X is equal to under root u, and here what we are having, x is equal to log of v. Okay, look at it properly. Okay, so these two equations we are getting. Now what is this value? So these two equations are having their own separation. Now if I look at, therefore now what should be our y? So I am keeping this y separate right now, okay, over here only. Now if I differentiate this with respect to u, so this is equation number 1. So I would like to make this equation 2 separately. So equation number 1 and this is equation number v is equal, sorry, x is equal to v log of v. This is equation number 2. So differentiating both equations, so both equations instead of both sides of equation 1 and 2 with respect to u and v respectively, what you will get, dx upon du is equal to what? 1 upon 2 times under root of u. I am writing it directly, and dx upon dv is equal to 1 upon v, most important, 1 upon v. Now here another one factor is important. What is that, sir? Here we are differentiating and we are getting the values. Now interesting parameter is what? We have du upon dx is equal to how much? So du upon dx is equal to 1 upon dx upon du, and dv upon dx is equal to 1 upon dx upon dv. Now we can substitute the values directly and we will get the answer. So du upon dx is equal to what? So du upon dx is equal to 2 under root of u. What is the value of under root of u? Is nothing but x. Okay, so which is nothing but x, and here dv upon dx is equal to what? Is equal to 1 upon this v. So 1 upon v again converts to what? V. So this v is nothing but what? E raised to x. You can see what is the value of v? E raised to x. Now we can pick up these values and say something like this. So hope you are getting what I am doing. Okay, so I am doing one simple thing. The simple thing simply indicates on one particular parameter. What is that? We are dealing here with this y is equal to x square and this falana dapana. Okay, but the main problem is what? If you want to find out the inverse of y directly, we cannot find it direct inverse. Okay, so we need to move through this whole process. So this initial step is not useful. What we need to do, we need to consider this as a u, this is a v. Okay, and separately if we put, so we will get the inverse process we are applying within this u and v, and we are getting this du upon dx. Okay, which we were doing, okay, in initial problems, and we are doing here simultaneously 2 times, okay, within one question. So that's how this question is interesting. Now therefore, now this is equation number, okay, so differentiating y with respect to this. So therefore, so again the solution is remaining over here. So that's how the solution was started, okay, at this point. Here y is equal to what? U dot v, differentiating both sides with respect to x. What you will get? Dy upon dx, which is equal to u dot dv upon dx plus v dot du upon dx. We have these values. So substituting these values from equation number, this is equation number 3. So from equation number 3 we can substitute this value. And what is the value of u? What is the value of v? We already considered it. So therefore that value is what? X square into dv upon dx is what? E raised to x plus what is the value of v? E raised to x. And what is the value of du upon dx is 2x. Sorry, I forgot to write 2x. Okay, so 2x. Again simplifying it, what you will get? E raised to x common, in bracket x square plus 2x. Most of you can be written in this form also. X is also common, so can we take it common? Yes, you can take it common, but the answer is this. Okay, so hope we are correct up to this point. So we are finding these values. Okay, so this was the answer which was found by me. Now they are asking you in different terms. Now what is that most important pattern and how we are working on this pattern? So find the derivative of inverse function of the following. Now most important thing, now this is our common differentiation which we have performed. Okay, now what we need to do, we need to inverse it. Now commonly we have the in terms of inverse function. So in terms of inverse function we are getting these values or not? Yes, of course. So what is that? So dx upon dy is equal to 1 upon dy upon dx, and again using this equation number 4. So equation number 4 says something like this. So substituting the equation number 4, e raised to x into x e raised to x, x e raised to x into x plus 2, and that's what our final answer is. Okay, I am doing quite long cut process. Okay, so I am performing some kind of long process, but here you need to understand this is not a shortcut. I know this can be done in very simple way, but I am telling you how exactly we are finding these values step by step. Hope you are getting these values. So let's move to further question. Our further question is, so next question is dy upon dx of the following function we need to find out, but using the inverse functions derivative. So inverse function derivative we need to find out. So our next question is what? Y is equal to x into cos of x. Okay, so x into cos of x, y is equal to x into cos of x. Now what I would like to do, I would like to directly differentiate this function. Okay, I can get dy upon dx directly. Now they have asked us one important thing, that we need to differentiate it and find the inverse. So what is the inverse of this function? If y is equal to f of x, okay, then x is equal to inverse of y. Okay, understood. Now differentiating both sides with respect to y, so dy upon dx is equal to what? 1 upon dy upon dx. Now this is called as derivative of inverse function. So this is inverse and this is derivative of inverse function. Okay, so initially that's what I wanted to emphasize. Okay, but if you look at it properly, so dy upon dx is equal to 1 upon dy upon dx. So dx upon dy is equal to, so this is the derivative of the inverse function. So here they have given us y. So if you find out dy upon dx and take its reciprocal, definitely you will get the dx upon dy, and that's how this is so simple. So note it down, this is the most important parameter. Now here our problems will start. So differentiating both sides. So let y is equal to x cos of x, differentiating both sides with respect to x. Okay, what you will get? Dy upon dx, which is equal to how much? So x into cos of x, derivative will be x sin of x, which is containing minus sign, plus cos of x into x, derivative will be 1. So here will be 1 in answer. So next step is very easy, as you can guess. Okay, so guess over here is something like this. Okay, so this will be in separation. Now next step is what? I would like to simplify this term. So dy upon dx is equal to how much? So cos of x minus x sin of x. That's it. Now what's our next step? We need to substitute this value in this equation. Now if I write it simply like this, derivative of inverse function. So derivative of inverse function will be, so derivative of inverse of y is dx upon dy is equal to 1 upon dy upon dx. Hence substitute the values from this equation. This is equation number, which one? 2 or 1? 1. So from equation number 1, what we are getting? 1 upon cos of x minus x sin of x. Now picture is clear how to differentiate this kind of thing. This is the game of words. Okay, so if you look at this game properly, how exactly they are dealing with this game is, they have given us a y and they are asking us to find out the derivative of x derivative of its inverse. If we were finding initially the inverse of this function, okay, this kind of function, okay, which contains the product of two functions. Okay, so within this composite function it is quite difficult to find the inverse. Okay, the composite function's inverse is quite difficult. Most important point is that. Now what we need to do? So we need to find its inverse, then we need to differentiate it. So if I consider like this, y is equal to f of x, then I consider that x is equal to inverse function of y. Then if I differentiate it, then what we will get? So we will get dx upon dy is equal to 1 upon dy upon dx. So that is what called as derivative of inverse function. Hope you understood. So on that basis we are solving this problem. Now next problems is also easy. So x into 7 raised to x. Okay, so initially I was solving this problem just because to make you sure how exactly we are dealing with that process, and I had used this formula initially also. Now again I am putting this formula and solving the problem. So next step, our next problem is something like that, something y. So question number 3. Okay, so I am giving you directly solution. Y is equal to x into 7 raised to x. Hope I am correct. Let's check it. Yes. The next step, again differentiating both side. So differentiating both sides with respect to x. I would like to give this equation as 1. Okay, so differentiating both sides with respect to x of the equation number 1, what you will get, dy upon dx. What is this? X into this. So x into 7 raised to x. So what is the derivative? So log of 7 plus 7 raised to x into derivative of x will be 1. So I am no need to write it. Okay, so no need to write it. So this is sufficient? No, it's not sufficient. So we need to again simplify it. So 7 raised to x into x log of 7 plus 1. Hope everything is fine. Now next step, what is that? So y is equal to f of x. Again y is equal to f of x. So same process we are applying. Now we need to say it directly that derivative of inverse of y is, so derivative of inverse of y is dx upon dy, which is equal to 1 upon dy upon dx, which is equal to again 1 upon 7 raised to x into x log of 7 plus 1. Just check the answer whether we are right or wrong. Okay, so yes, we are correct. So that's how we are dealing with this problem. So as you can see, within the 2 to 3 steps we are solving this problem. Okay, just what we need to do, we need to perform this formula by using the UV rule. Okay, so again within the UV rule we are not applying the different kind of functions. So same function we are having. So simple function is there. There is no what we can say composite function. So it was easy to differentiate over here. Now let's move to further questions. So there are so many questions, so we need to be fast. So y is equal to x square plus log of x. Again this is composite function. Here also we need to take care of few things. So I would like to erase all this stuff. These problems are easy. Okay, these problems why they have given you. Okay, if you solve by your old method, so it is possible to find the answer, but why they have given us for that only trigonometric functions, inverse process, understanding of that inverse process of the trigonometric functions. That's why we are dealing with this inverse functions. These are the polynomials. Okay, this is also polynomial or exponential function you can say, and this is what trigonometric function. So trigonometric functions, logarithmic functions, exponential functions and inverse trigonometric functions, we need to find out their derivative by applying this inverse differentiation, inverse function differentiation. Now next step, question number 4th says something like this: y is equal to x square plus cos of x, yes, no, log of x, this is equation number 1. Now differentiating both sides. So differentiating both sides with respect to x. Okay, so what you will get, dy upon dx, which is equal to 2x plus 1 upon x. I am writing it directly. Okay, so hope you can differentiate it directly. Okay, all of you are performing this, otherwise we need to again put that step by step, dx upon dx of x square plus log of x, which is d upon dx of x square plus d upon dx of log of x. So quite this kind of thing we need to apply. So again here what we are applying, so 2x plus derivative of log of x will be 1 upon x, that's it. Now next step, this is what, dy upon dx. So this is equation number 2. Now again I am using this statement. So derivative of inverse of y is dx upon dy is equal to 1 upon dy upon dx. So any guess So, we need to just substitute these values. So, 1 upon 2x plus 1 upon x, which is again on simplification what we will get, x upon 2x square plus 1, that is it. Just check the answer. Okay, so I am making the like base, okay, and values are shifted. So, if you have any doubt regarding this, so I would like to give the solution for this step also. Okay, so everything is quite easy so far and smooth, as you can see. So, answers we are getting directly without any problem. Okay, so if you solve it, definitely you will find the answer, but solve it on your own. Now, next step is what? How we are getting this value. Okay, so I would like to again illustrate that dx upon dy is equal to what was that? So, 1 upon 2x plus 1 upon x, which is equal to what? Which is equal to 1 upon, making like base, 2x square plus 1 upon x, 1 upon x, which is equal to 1 upon 2x square plus 1 upon x, and this x goes to upper side. So, which is equal to x upon 2x square plus 1. Just look at it properly, everything is given over there. So, all those remaining steps I am performing directly over here and finding the answer. Okay. So, no one will ask you this steps how you are getting. So, those are the elementary processes. Now, let us move to further question. What is our further question? Further, there is one important parameter. What is that? Question number 5th, x log of x. Again, this question is easy. Okay, hope you are getting this question's answer. Okay, directly. Is too much sweating. Okay, from last 2 to 3 days. So, quite cloudy atmosphere we are facing and lots of temperature. Now, next step is what? Our next question is y is equal to, what is that question? Y is equal to x log of x. So, question number 5th says that. So, we need to say here, let y is equal to x log of x. Now, here is again interesting parameter. So, differentiating both sides with respect to x, what you will get? Dy upon dx is equal to x 1 upon x plus what? Log of x into 1 by applying UV rule. So, this is u, this is v. Okay. So, I am writing it directly, those who are looking this equation. Okay. So, they should look at it in this form. So, differentiating both sides, I am getting this. So, what is that final answer? So, 1 plus log of x, that is a very beautiful answer. Now, next step, what we need to do? We need to say the derivative of what? Derivative of inverse of what? Y is dx upon dy is equal to 1 upon dy upon dx, which is equal to what? 1 upon 1 plus log of x. So, simple. Now, next step, nothing to do with this. So, there is no next step, further step. So, that is the final answer, just look at it. Okay. So, all these questions are regarding to one particular format. What we need to do? We need to find out the dy upon dx is equal to something something, and again simplifying this, and again saying the final statement derivative of the inverse of the y is this, and dy upon dx upon dy is equal to 1 upon dy upon dx is equal to 1. Okay. So, on that base, this is the main parameter. Okay. So, initially they have given only the theorem in terms of what? The theorem was in terms of dy upon dx is equal to 1 upon dx upon dy. So, this was the theorem na. So, we are making its opposite parameter and finding the derivative of that inverse. So, why that is important? Okay. So inverse has its own identity in mathematics. Okay, so inverse is most important parameter of the mathematics. So whenever we are having any particular number, so we need to apply those assumptions and find whether applied equation of our kind of thing is possibly plot on the graph. So all those possibilities, when we are counting, at that time we need to count the inverse process also. Therefore this inverse of any function is important. Okay, next step, the derivative of that inverse is also important, and that's why we are finding this inverse. Okay, now next question is what? Question number 3. So within the question number 3, same process we need to apply. Here what we need to do, we need to find out the inverse, okay, as we were finding here, and again at particular point x we need to substitute the value, and the value is given over there. So the question is says something like this: find the derivative of the inverse of the following functions and also find their value at the point indicated against them. Okay, so that's what we need to do. At x is equal to 1, we need to find the value. So how to do it? Okay, most important part, how to do it. So we need to find the derivative first thing. Okay, so we will find it. So should I erase this? Yes. So we are starting with the question number 3. Okay, this question is also easy. The most difficult part will start with these trigonometric functions. So inverse trigonometric functions are quite difficult to understand and to apply. Why I am saying that? I am saying just because of only one thing, because as the things are looking right now, okay, those are not the cases. That's a different scenario over there. So be careful about these questions. Now next question is what? Question number 3. So question number 3 says something like this. So we need to find the derivative of the function, inverse function's derivative. So y is equal to given, y is equal to what? X raised to 5 plus x 3x, sorry 2x, okay, now the picture is clear. X raised to 5 plus 2x cube plus 3x, x raised to 5 plus 2x cube plus x square, no 3x only, 3x, okay, add x is equal to 1. Most of you have this query. Okay, so people are smart but not that enough. Okay, so they are thinking like they substitute the value of x is equal to 1 and again differentiate, the answer will be dy upon dx is equal to 0, and so 1 upon 0 is not defined. Okay, that's not the case. Listen carefully what I am saying. Okay, so what we need to do, we need to find out the derivative first, so differentiating both sides of the equation. Okay, so this is the last case. So let, now solution comes here, let y is equal to x raised to 5 plus 2x cube plus 3x. Now differentiating both sides with respect to x. Now most important thing is done. Now next step, dy upon dx is equal to, anybody can answer it. So 5x raised to 4 plus 6x square plus 3. That's the derivative. That's the derivative. Now again important parameter. Now dy upon dx at x is equal to 1. What should be the answer of this? Now what should be the answer? So this is nothing but equals to, okay, so this is what our required value. So this is what the required value. So what should be this? So this is again nothing but 5 into 1 raised to 4 plus 6 into 1 raised to 2 plus 3, nothing else. So which is again 5 plus 6 plus 3, how much? 5 plus 6, 11, 11 plus 3 will be 14. Understood? So give this equation number what? 2 1 1. Okay, so let's move to this side. Again we can use that statement. So derivative of the inverse of y is derivative of inverse of y is instead of is I would like to say at at x is equal to 1 is dx upon dy is equal to 1 upon dy upon dx at x is equal to 1, which is equal to 1 upon 14. Just check the answer. Okay. So, that is the simple way to solve this kind of questions. So, hope you like it. So, this is the simple question. This was simple question. Now, again I need to apply on this side also. So, I will erase this much, and this much. Oops, our Shri is disturbed. Okay. Now, next step. So, what is this? This was the question number 1. Now, question number 2 of the question number 3. No, this is the final answer. Okay, hope you got it. Now, next step. What is question number? Question number 2 is something like this: y is equal to e raised to x plus 3x plus 2 at x is equal to 0. So, y is equal to e raised to x plus 3x plus 2. Hope I am correct. Yes, at x is equal to 0. So, at x is equal to 0. So, differentiating the above equation or both sides with respect to x, what you will get? E raised to x as it is. Okay, I need to erase this also. Okay, so e raised to x as it is plus 3x. What is the 3x derivative? Will be 3, and what is the derivative of 2? Will be 0. So, this is the final dy upon dx after differentiation. Now, at dy upon dx, okay, when x is equal to 0 is equal to how much? 1 plus 3, which is equal to 4. This is equation number 1. Now, again look at this step by step. So, if I substitute, e raised to 0 will be 1. So, 1 plus 3 will be 4. Okay. So, common sense. So, this gives the dy upon dx at x is equal to 0 will be equal to 4. Now, the derivative of inverse of y at x is equal to 0. What should be? So, dx upon dy at x is equal to 0 is equal to 1 upon dy upon dx at x is equal to 0. So, what should be? So, 1 upon 4. That is it. As you can see how these questions are easy. Okay. So, these questions are quite easy. So, I would like to move fast. So, question number 3. Okay. So, can we talk about the question number 3? Yes. Again, this question is also easy. So, question number 4 is also easy. So, every question of this question is easy, but you need to follow the steps, then only you can find the answer. Okay. Now, next step. Okay. So, I will erase this much, this part. Okay. Everything is fine up to this. Now, this. Okay. Hope you don't like it. Okay. So, but it's a shortcut for me. So, what is that? Next question: 3x square plus 2 log of x cube. 3x square plus 2 log of x cube at what? X is equal to 1. We need to find it out. So, again that writing this equation: 3x square plus 2 log of x cube. Hope I am correct. Yes. Now, differentiating both sides, what you are getting? So, you will get the very interesting pattern, but this equation has some importance. So, this is what? Okay. So, these 3 will come outside and this will be 6. So, log of x we need to find only. Understood? So, log of x we need to find, and then log of x derivative will be something 1 upon x. So, differentiating both sides, what you will get? 6x plus 6 what? D upon dx of log of x. Hope you like this step. Okay. So, I am doing it directly. Why? Because this 3 power will come here. Understood? And that will be 6, and remains what? Log of x. So, what is the derivative of log of x? That will be 1 upon x only. Now, we can take the 6 common. So, 6 taking 6 common, what remains in the bracket? X plus 1 upon x. Now substitute the value at x is equal to 1. What is the possible value? Okay, so 1 plus 1 will be 2. 2 into 6 will be 12. How much? 12 only. Now this is the value which we would like to substitute in this equation. So at x is equal to 1. Okay, so derivative of inverse of y at x is equal to 1 is equal to dy upon dx at x is equal to 1, which is equals to 1 upon dy upon dx at x is equal to 1, which is equal to 1 upon 12. That's it. Just check the answer whether we are correct or wrong. Yes, we are correct. Now next step, our next question. Oops, I erased it totally. So what we need to do, we need to substitute the value. So this question is quite lengthy, so I hope so, because there is something called as sine. Okay, sine of x minus 2 plus x square at x is equal to 2. We need to find out. Okay, so I am solving this question. Oops, this question was third. Okay, this was the third question of the third, and now we are moving towards the question number fourth. Okay, what is that? Let y is equal to sine of x minus 2 plus x square at x is equal to 2. Okay, so differentiating both sides, with respect to x. What are you getting? Okay, hope you are getting so many things, but there is one certain thing. What is that? Dy upon dx is equal to sine of x minus 2's derivative will be what? Fast. It's nothing but cos of x minus 2 only. Okay, now what's about, sir? X minus 2's derivative, again it is 1, so therefore no need to differentiate further. Now what is the derivative of x square? That will be 2x only. Okay, that's it, nothing else. Now dy upon dx at x is equal to 2. What should be the answer? So 2 minus 2 will be 0, the cos of 0 will be 1. So this is what? Cos of 0 plus, what is this? 2. So 2 into 2 will be 4. Again 1 plus 4 is equal to 5. Be fast. Now next step, differentiating both sides, that's done. Now derivative, again the same statement, derivative of inverse of what? Y at x is equal to 2. Understood? So dx upon dy at x is equal to 2 is equal to 1 upon dy upon dx at x is equal to 2, which is equal to 1 upon 5, and that's what our final answer is about. Now this question was also easy. If you listen it carefully and if you understood how to solve this problem, it is quite easy. But if you confuse yourself by applying so many different steps, then these problems are not that easy. They will confuse you till you lose. Okay, so be prepared for this kind of questions. Now next question. Okay, so these questions were kind of easy. We solved them so fastly. Now next step is what? Our question number 4th. It is again same, but we need to understand what is given over here and what we need to perform. Okay, so I would like to perform this question number 4, and you are also following me, hope so. Now next step is question number 4. Okay, it's not that easy. Here we need to understand so many factors. Now this book, I like this book so much, this new syllabus book, because they are now they are talking in terms of mathematics. Okay, so initially whatever the given was like 8th standard, 12th standard, they were not that comparatively mathematical statements. Now these statements are, this type of questions are quite important. So please underline this question as IMP, very IMP, or IIMP or VVIMP or whatever you want to do, but this kind of question will be asked in your exam, that is for sure. Why? Because these are the dealing with mathematics and the understanding of that equations. Now what is the question? If f of x is equal to, what they are saying, f of x is equal to x cube plus x minus 2. Now question number 4th is given, if f of x is equal to x cube plus x minus 2, x cube plus x minus 2, what? Then find the inverse derivative of 0. So find, now understand the meaning first, okay, what exactly they are asking for. Okay, now here we all of know, so let we know this thing, let y is equal to f of x, okay, that is for sure. Now next step, x is equal to f dash of y, that is also good. Now most important steps come. What is that? What we need to find out, this is what the inverse, sorry, this was the inverse. The most important steps comes. What is that? We need to find the derivative at x is equal to 0. So if I write it like this, so dx upon dy is equal to f inverse derivative of y. Now what it means? What it means? So this is nothing but, all of you should understand this, what exactly we are doing over here. This is nothing but, so this equation is quite difficult to understand. So this is what you need to put, this y is equal to 0. Now if y is equal to 0, then what should be the scenario? What should be the value of x? Okay, so there should be some value of x, and that value of x again we need to substitute. Understood? So that's how this question is difficult. So here you need to find out, and I would like to again mention it properly. So dx upon dy at y is equal to 0. So f dash of f inverse of that derivative will be equal to 0. Understood? And that's what we need to find out, as you can see over here. Understood? And that's the major concept, when this x is equal to 0 and this value will be found. Understood? Hope you got the essence of this problem. So I am first of all taking this problem directly and giving you hint how to find the whatever the required values. So this is what required, and this means this dx upon dy at y is equal to 0. Now when that y is equal to 0 is possible, it should have some x value, then only that y is equal to 0 is possible. Now what is the value? So this is nothing but 1 upon dy upon dx at x is equal to something something. So that something something we need to find out. Okay, so at x is equal to something something, y is equal to 0. So y is equal to 0. Okay, so that's what we are performing. Okay, now let's move and directly substitute the values. Okay, you got it? What we need to do? We need to find out the value in these terms. Now I will erase this. So note it down. This is the important step, and you need to understand what is the meaning of this f inverse dash of 0. Okay, hope you got it. Now I would like to directly differentiate the values. As I differentiate the values, what you will get? Okay, so similarly, so let f of x, or f of x instead of f of x, what we need to do? Y is equal to f of x is equal to x cube plus x minus 2. Okay, so we have considered this. Up to this everything looks fine. Now again important thing is what? F, so differentiating both sides, with respect to x. What you will get? You will get f dash of x is equal to 3x square plus 1. Okay, 3x square plus 1. Now, again we have so at y is equal to 0. So, as I said you or told you this 0 is nothing but y. So, y's value is what? 0. So, we were discussing about it. Now, y is equal to 0, corresponding x is equal to how much? Corresponding x should have some value. So, at this y is equal to 0, if it is 0, then x should have value of 1. What? Value of 1. So, that 1 belongs to. So, I would like to perform over here one particular task at y is equal to 0. So, y is equal to 0 is what? X cube plus x minus 2 is equal to 0. So, x cube plus x is equal to 2. So, x into x square plus 1 is equal to 2. So, therefore, at x is equal to 1, at x is equal to 1. Okay. So, this is the possible case. Understood? The solution is simply says that, so x is equal to 1. Okay, there should not be any other value. If you apply the minus 1 or something, then it's not equals to 2. So, this x square, so x square plus 1 is equal to 2 only when, okay, so only when at x is equal to 1. So, if you substitute x is equal to 1, then only your LHS and RHS matches. So, therefore, x is equal to 1 is corresponding value at y is equal to 0. So, I am putting over here as corresponding value 1. Now, next step, if you move properly, so what you will find? So, f dash of what? So, f inverse dash of y is equal to 1 upon f dash of x. Most importantly, this is what we have learned. Now, f inverse of y, so f inverse dash of y is equal to 1 upon f of x. So, this is nothing but dx upon dy is equal to 1 upon dy upon dx. Okay. So, these two equations are similar. We are not using this equation, we are using this equation. Again, at y is equal to 0, x is equal to 1, substitute this value. So, what you will get? F inverse dash of y is equal to 1 upon f dash of 1. Now, what is the value of f dash of 1, sir? So, f dash of 1 have some value. So, it can be picked up from this position. So, we need to substitute that value. So, 1 upon 3 into 1 plus 1, which is equal to 1 upon 4, and that is the final answer of our question number 4. Okay. So, hope you like it. Now, what I was conveying to you, that how to find this corresponding value of 1 and what is the importance of this problem, as I discussed earlier. So, this problem is quite important, and this just I told you, just tick it, because this kind of question they will ask in exam. So, here up to this 1 mark, up to this step. Okay, so finding the corresponding value of x 1 mark, and the final answer will be for 1 mark. So, as it contains 3 marks question. So, this is the 3 marks question. Can you imagine? So, this kind of question they are asking in exams. So, hope you like it. Now, we will discuss this question number 5 and their trigonometric functions properties. Okay. So, in next lecture. So, please prepare those problems. So, those problems will be in different phase, and you are in different phase right now. So, those problems are not that difficult, but again these are the trigonometric functions which nowadays, okay, so nowadays these are the haunting concepts for the students. They're thinking like they are learning some alien technology, okay, and that's how this sec, tan, cot has came to earth. That's not the truth, okay. So these are invented by us way before 2000 year ago. So now we need to start with these trigonometric functions, and most importantly we will discuss it, okay, in terms of derivatives, how we can find the derivative of this inverse function. Okay, so thank you for watching this, and please, if you didn't subscribe our channel, please subscribe it, and please share with your friends. Thank you.